Welcome back to section 9.2. The next thing we're going to do is rewrite equations using function notations and then find specific values. So the first equation I've got for you in example 3 is x plus y equals 4. You'll notice it's not in function notation yet. It's not, f of x equals something. So what we're going to do to get it in function notation is basically you're going to solve for y. And then you'll just replace a y with the f of x. That's it. Okay? So it's really not too terrible. Okay? So with our first one, if I want to solve for y and get y by itself, all I need to do is subtract x from both sides. So I'll have y equals, and I could either do 4 minus x or negative x plus 4. I'm going to choose to do negative x plus 4 because that's a format that is pretty well known. That's that slope-intercept form. So that's a nice format to have things in. And then I'm just going to replace my y with an f of x. And so now I've got f of x equals negative x plus 4. And we are magically in function notation. Next up, it says to find f of negative 3. So if I have negative 3 for x, it's just asking what's f of x or what's the y value. So I'm going to substitute in negative 3 for x. So that would look like the opposite of negative 3 plus 4. Well, the opposite of negative 3 is positive 3. And then 3 plus 4 would be 7. So f of negative 3 is 7. All right, next equation I have for you is x squared minus 4y equals 3. Let's get it in function notation first. So we'll solve for y and then replace that y with an f of x, okay? So if I want to get y by itself, I'll just subtract x squared from both sides. So I'll have negative 4y equals negative x squared plus 3. I'm just writing it in standard form where my highest exponent variable is first. And then I'll divide everything on both sides by negative 4 to get my y by itself. So I'll have y equals, I'm going to have a negative 1 divided by negative 4. So that just simplifies to a positive 1/4 x squared. I'll have a 3 divided by negative 4, so that's negative 3/4. And then I'll just replace my y with f of x so that it is in function notation. So I've got 1/4 x squared minus 3/4 equals f of x. And now we're in function notation for that equation. Next up, we'll find f of negative 3. So I'm going to substitute negative 3 for x. So I'll have 1/4 times negative 3 squared minus 3/4. All right, well, negative 3 squared is positive 9. So really, I'm doing 1/4. I'm just going to do this to the side so you understand what I'm doing. 1/4 times 9. So that's 9/1. So then 9 times 1 would be 9. 4 times 1 would be 4. So that would be a positive 9/4 minus 3/4. All right, now that they even have the same denominator, we can subtract 9 minus 3 is 6. The denominators stay the same, it's 6/4. And then I can simplify that a bit because 6 and 4 are both divisible by 2. So I can simplify that to be 3/2. And that would be my answer. So when x is negative 3, y is 3/2, or f of negative 3 is 3/2. All right. Example 4 says, graph the function, and then we get to give domain and range again. So a little bit of review from last time, which is going to be pleasant, okay? But we're in that function notation. So my graph of my function, so when it has f of x equals negative 1/4 x plus 2, if it helps your brain a little bit, that's the same thing as y equals negative 1/4 x plus 2. So we've got a line. The y-intercept is 2. I'll go ahead and plot that. My slope is negative 1/4. So that means that to get more points, I can go down 1 and right 4. Or I could go up 1 and left 4. Doesn't really matter. And I'll connect my dots to form a line. Okay, so I already have my line made. And see, we have to give domain and range. Those won't be too bad. So domain, how far left do I go? I keep going forever, so that's negative infinity. How far right do I go? It's positive infinity. It keeps going forever. It doesn't miss any points in the middle. So that's my domain. It's all real numbers, negative infinity to positive infinity. For the range, you're wondering how far down does our graph go? Well, again, we have arrows. I know it's going down very slowly, but I promise it's just going to keep going down and keep going down and keep going down. So that'll be negative infinity. How far up does our graph go? I know it's going up very slowly, but it's just going to keep going up forever. So that would be positive infinity. It doesn't miss any values in the middle, so we don't have to skip over anything. And we'll have parentheses on either end because those are infinities. Now it's your turn. You guys get to try one and show me how much you've learned.